Okay, so here is 9, 7, and 9, 8 in Algebra 1. 9.7 is all about the different types of models that are out there, and in class we're going to do something called the penny circle, which explores this. And then 9.8 is learning more about solving systems. So let's do a little overview. In 9.7, there are three basic kinds of functions that we've talked about in class so far: linear, quadratic, and exponential. Okay, so linears are lines, quadratics are parabolas, exponentials have this shape here. We want to be able to tell the difference not only from the graph but from tables, and here is the idea of how you do it from a table. The first table represents a linear function, and if you take a look at the difference here of my y's and my x's, I have a common difference for every change in y for simple change in x. So as an example, 9 to 7 is a difference of -2, 7 to 5, -2. So for equal changes in x, I have a equal change in y. That's the definition of linear. Take a look at this second one here. This is a quadratic table, okay? If I do the first difference, such as, 11 and 8, I would get -3. 8 and a 7, I would get a -1. A 7 and an 8, I would get a +1. And then an 8 and 11, a +3. Notice those are very different, right? So it's not linear because that first difference is not constant. But if I take a look at the second difference, i.e. the difference of the difference, 3 and -1 is a +2. -1 and a 1, a +2. 1 and a 3 is a +2. That represents a quadratic model. That's pretty cool. So for equal changes in x, I get equal changes in the second difference. That represents a quadratic model. And then the third one would be exponential. So if I'm going from 1/9 to 1/3 to 1 to 3 to 9, if I am multiplying by a factor that is constant for equal changes of x, then I have an exponential model. So that's kind of a way you can choose the difference just by looking at a table. And that's basically what 9.7 is all about. 9.8 is a little bit different. Okay, 9.8 is showing us how to solve systems of linear and quadratic models. So let me give you like a little example here, and then we'll dive into it using the calculator and what we would do. So let's say I'm trying to solve x squared minus 4x minus 1. That's a quadratic equation. And solve y is equal to 5. That's a linear equation, and this represents my system. Well, the only solution is the point of intersection where they would be, which would be the point 2, looks like -5. So I'd have to check and make sure that when I plugged 2, -5 in for x and y in both of my equations, I would get a true statement, okay? So we can use the calculator here to show us how this would work. So there will be three types of problems that we can do. And we would use the calculator here to graph both of these and see where they would intersect. So for A, there'd be 2 points of intersection, namely right there and there. For B, another 2 points of intersection. And then C, there might be some where some systems we can't solve them together because there's no points of intersection. So let me show you really quick how you can do like the first one here on your calculator. So if I pull my calculator up, I would turn it on. I would go to y equals, I would plug in each of those. So I'd plug in an x squared minus an x minus a 2. And then on the second one, I would plug in an x plus a 1. Okay. I'm going to hit zoom 6 to make sure that I'm looking at the exact same screen as this. And of course, this picture matches this picture. That's good. And here are the answers, but how do I get them on the calculator? I go second, trace, which brings up the calculate button. Go to option 5, which is the intersect, and move my calculator, or move the little blinking butterfly close to the first point. Asking if I'm on the first and second curves, push enter, and I will get a -1, 0, which is what I get right there. We did this in class, so it should be very, very familiar. I'm just showing you quickly. How about how to get the other one? Well, do the same thing. Go second, calculate, go to option number 5, that's the intersection of the two, and move that blinking butterfly closer to that point and have it bounce between the first and second curves. Push enter a couple of times, and of course, there's the 0.34, which is exactly what it says right down there. So you can use your calculator to solve them. You can also use algebra to solve them, and that's what we're going to do in this example here. So notice I have y is equal to negative x plus 3, and y is equal to negative x squared plus 4x minus 1. Well, we can set those two things equal to each other. So I can say negative x plus 3 is now equal to negative x squared plus 4x minus 1. I can simplify this a little bit more. I can move everything to the left-hand side. So I would have an x squared. If I subtract 4x from a negative x, I'd have a negative 5x. And if I add 1 to both sides, I'd have plus 4 is now set equal to 0. Well, if I can factor this thing, I'm going to try and go ahead and factor it. Can I do that? Let's see, x and an x, probably a 4 and a 1. If it was a minus and a minus, yeah, looks like I can do that. So this tells me that x is going to equal 1 or x is going to equal 4. If x is equal to 1, I can plug it right back in here and see that y would then have to give me negative 1 plus 3 is a 2. Okay, and if x is equal to 4, plugging it right back in there, negative 4 plus 3 is a negative 1, so I'd be negative 1. So my two solutions would be 1 comma 2, which is that point right there, and 4 negative 1, which is that point right there. So we can also do this using algebra. Okay, let's have you try one, see what you come up with, and see if you get the right answer. Okay, hopefully you got the right answer. And here it is right here. So plugging in and going, I end up with a 0, 1 and a 3, 4 just by substituting and coming up with the two solutions. Okay, there you go. That's 9, 7 and 9, 8, a good overview. You should be good to go from there.